All right, so 9.6 is us using your transition matrices, which allows us to dictate where people are going. So remember, we did the easiest example for us to look at is the one with the shopping market A versus market B. How many people who shop at A will then continue to shop at A versus how many people shop at A will then move away. So then there's a percentage that tells us where they're going or if they're staying. So the only extra bit to make this a bit more challenging is where we have people who are added into the situation and we have people who are removed from the situation. So the example, so the name behind it is restocking, so adding something to the transition situation, or culling, which means to remove, so removing something from the transition situation. So in other words, this is more, so we generally do this with animals and things like that because it's easier for us to keep count. That sometimes when you breed certain things, you might add extra eggs to the batch or sell them off, so you're removing them from the situation, that kind of stuff. So with this, it just means your transition matrix isn't just a simple multiplication anymore. Well, example one, pretty full on. But essentially, with your transition matrix system, there's also a plus and minus component. So to give you the recursion, this is what the recursion is. So we already dealt with this first component. So the first component is the next transition event. So the next day or the next month is the transition matrix times by the previous. The only thing that's added that's new is this plus B bit, right? So plus B is not necessarily adding to the situation. It could also be removing. So sometimes you might plus a negative number, which really means to remove. So going through this first example, the example is a company wishes to start a commercial whiting breeding farm. So they start off with 20,000 whiting eggs and then 4,000 baby whitings and 500 adult whitings. So in each year, these are the things that can happen. So eggs, they could die or they could live and become babies, right? So E can either become babies or they can die. Baby whitings can either die or they could live and become adult whitings. So with B, they're babies. So they're not going to go backwards to become eggs again, and they're not going to stay as babies. They're either going to transition and grow to become adults, or they're going to not make it and die. And then with the adults, they could either die or stay alive, but eventually die. So adults, they can either stay as adults or they can die. And the thing is, once it's dead, it will be dead still, yeah? So it will remain dead. So this is going from 1 year to the next year. So here it is, E represents the egg, B represents the baby, A represents the adult, D represents dead. And then initially, S0, this is once again E, you got 20,000 eggs, you got 4,000 babies, you got 500 adults, but none of them are dead, okay? So this is the initial scenario. Now, it also adds that the company removes 500 adult whitings each year to sell to the restaurants, yeah, which that's how they're going to make profit. But it adds an extra 200 baby whitings each year, 200 babies, yep, and estimates about 800 extra eggs will be laid by the adults during that year. So then this is where you're going to be adding into the situation or you're going to be removing from the situation. So the question is, find your B matrix. So the B is the extra restocking or the culling or removing of these particular items. Well, in this case, your sharks. So this is what it looks like. So we're adding in, so it says that we're adding in 8,000 extra eggs. So here it is with the eggs. So remember, the lettering stays exactly the same. We're adding 200 babies to the farm, but we're removing. So that's why it's negative, because we're removing and we're selling them off to restaurants. So 500 of them, 500 adult whitings, we're selling them off. So we're removing them from the system. So that becomes your B matrix, yeah? And then we're not introducing any dead ones, so 0 for D. So that's the extra bit that you guys will do. So at the end of the day, it's all about following your recursion. So at the end of the day, if you want to see how many of each that you have, so how many eggs, how many babies, how many adults, how many dead next year, essentially you just got to follow the recursion. So that's working out B, which is the extra bit of restocking or culling. So it says find the number of adult whitings after 1 year. Well, here's my recursion. I know that in my very first initial year, this is S0. I need to times it by T plus my B matrix to give me my next, which is S1. Yeah, so S1 is my next event. I need to work with S0, right? So S0 will be my initial. So when you get to piece all this together, this is what the recursion looks like. From the recursion, all I'm doing is I'm replacing it with all my matrices. So here's my T matrix. So that was given to us at the start. Worst case scenario, they'll give you all the percentages and you would have to construct the matrix on your own. S0 was also given to us from the start. So here it is. And then this is the extra bit, so that every year you're adding in extra eggs, you're adding in extra babies, but you're removing the adults to sell off to the restaurants. So then once you put all this into CAS, this is a number that you will get. Once again, because we're dealing with the context of whitings, we can't have like 0.2 or 0.8 or 0.75 of a particular whiting. What needs to happen is you need to go through and round it to the nearest whole number. So with this, these are the numbers that we have. So the question is, how many adults are you going to have at the end of the first year? This is how many adults you're going to have, right? So you've got 8,000 eggs, 6,200 babies, 1,200 adults, and then 6,800 that didn't quite make it, right? But the question is just asking for the adults. So from here, you're just focusing on this. So then you'll highlight that, that's your answer, done. What if you want this in 2 years? So the thing is, because it's recursion, it means that if you want to work out the numbers in the second year, you're going to need the numbers in the first year. So lucky for us, we already worked at S1. So S1 works out to be this matrix. So now, in order to work at S2, you just need to apply the exact same thing, but this time you're going to replace this with S1. So S2 is the T matrix that's given, times by S1, which is the previous event, plus my addition, right? So things that I'm restocking versus things that I'm removing, that's what it looks like. So once again, this just becomes CAS work. So if you put this into CAS, multiply the 2 plus the B matrix, these are the numbers that you're going to get. So then it's asking how many adults that you're going to have now. 2,390 adult whitings is what you're going to be left with at the end of the second year. So then if they wanted the third year or the fourth year, you just continue this particular pattern. Now, because you're going through a process of adding that extra bit in, what happens is you're not going to get a rule. So these will only be operated year by year, because when you add the numbers in, it's going to change it when you multiply by T matrix. In other words, these will only be recursion. So there won't be any rules behind this. Okay, so that's just going through the first year and the second year. So now it says, instead of removing 500 adult whitings after the second year, the company decides to remove enough so the number of adult whitings remain the same as it was at the very start. So how many need to be removed? Okay, so at the start of this, we had 500 adults. The question is, how many do we need to remove after the second year for it to continue to stay the same as it was at the very start of this? So what we've got is, this is my second year, yeah? So S2. What I'm gonna do is I'm just gonna multiply the transition. So without adding anything extra, without removing anything, I just wanna see the number of whitings that are going to go to different places. So I wanna see where all the eggs go, do they hatch to become babies? I wanna see where all the babies go, I wanna see where the adult goes. And when I do, I end up with this particular matrix. So this is without. So I haven't added anything yet. So I've withheld this just for a second. So based off the transition and based off my system, what happens is this is where all the numbers are going to go. So all the babies would have had hatched and become babies or died. All the babies would have been adults, or some of the babies were introduced from hatching from the eggs, but nothing was introduced. So nothing is new. So I haven't added anything to the numbers. Now the question is, if I want this to remain the same as the very start, so the start was 500, that means I need to remove enough adults so that it's going to go back and match my value of 500. So the current adults at the end of the third year is this. I need to remove enough in order to obtain the original number, which is 500. So therefore, I need to remove 1,844 adults to bring it back down to the 500 mark. So that's to satisfy part D. Okay, so done. So then E says, okay, the company decides to start another farm under the exact same circumstance, but there's one change. So the breeder realized that the number of eggs laid by the adults whiting during each year depends on how many female adult whitings they had last year. So they come up with the following modified recurrence relation, where they've estimated that 50% of the adults, i.e. females, lay 200 eggs each year. Okay, so this is what's given to you. So they're saying that this is your recursion. So your recursion is going to be this. So this is now one big recursion saying that T matrix times Sn. Yeah, so T matrix times the previous event plus this. So they're not adding any eggs yet. They're adding in 200 babies. They're still removing 500 adults, but there's an extra addition. So they're saying now that with this, you need to multiply that by Sn. So this big matrix here times it by Sn and then add it all together. So there's going to be another plus to this. Okay, so this is what it looks like. So if you want to work out how many we're going to have for the first year, this is what it looks like. So for the first year, you got your T matrix times by the original. So the original stays the same. So the only thing that's changed is this big thing that sits here, right? So when you go through, this is what they've given you. So this is what we're going to use. So we're going to substitute S0 in. So your T matrix, this is your T matrix that was given to you guys at the start. S0, here it is, given to you guys, same thing at the start, plus 0 to 100, negative 500, 0, so plus that. Then this is the part E is where they introduce this extra bit at the end where they're saying, okay, there's another big matrix that you need to time by S0. So, okay, here's another big matrix times by S0. What they want you to do now is multiply these two plus this plus the multiplication of these two. So this is where it's just time consuming for you guys to put everything into CAS. So this is where you got to type it in, multiply it, and press enter. So this is all CAS work. So then when you do all the CAS work, these are the numbers that are going to return. So you're going to get, yeah? So you're going to get these numbers. So you're going to get 50,000 eggs, 6,200 babies, 1,200 adults, and then the number of deaths between them is 16,800. Cool. All right. So in other words, it's all about following the recursion that is given to you. So whatever they've stated, so the recursion, whatever it is, that's what you got to use. Now, the most basic one for us to use is the one that they've given us at the start. So the most basic one is this one, where it's just a transition matrix times by your previous plus whatever the change is. But if they want to get all fancy, which they do, they want to go, yep, there's an extra bit to the scenario, and whatever that extra bit is, you're then going to have to fulfill it by just substituting in the appropriate matrices and then doing the maths. So all of that will give you S1. So all of this will give you S1, and hypothetically, if the question asks, do this again to work at S2, that just means this becomes S2 because it's the next step. T matrix times by the previous one, which is S1, plus my B matrix, plus this extra bit times by my previous, which is S1. So that means the S1 will be substituted in here, and the S1 will be substituted in here, and then you got to do all of that again in the CAS to then find S2. So in other words, it's just an extra couple of steps on top. So follow the recursion.